Now we'll discuss how to disprove a statement. A statement is true or its negation is true. So in order to disprove a statement, we need to show that its negation is true. We will give the example of how to disprove the following statement. All primes are odd. The first thing we want to do is we want to make sure that we actually take the negation properly. And so let's first translate this statement into predicate logic. So the original statement is going to be for all x that are integers, if x is prime, then x is odd. And I'm using the predicate p of x to mean x is prime and o of x to mean x is odd. Now we want to negate it. When we negate it, the for any becomes there exists, x is still an integer, and when we negate an implication, we keep the premise with p of x, and we negate the conclusion, not o of x. So in English, the negation is there exists an integer that is prime and even. And in order to disprove the original statement, we only need to give that integer, and that integer that is prime and even is 2. So that is called a counterexample. 2 is our counterexample to show that that statement is false. So if you have a statement of the form for any a predicate holds, when you negate it, you go there exists, then negate the predicate. A counterexample is sufficient in those examples to disprove the original statement and to prove that the negation is true. Let's consider another statement to disprove. Let x, y, and z be integers. There exist x and y such that for any z, x plus y equals z. So let's write the original statement in predicate logic. So there exists x, which is an integer, and there exists y, that's an integer, such that for any z, also an integer, x plus y equals z. Now let's negate it. It's going to be for any x, that's an integer, for any y, that's an integer, there exists an integer, z, such that x plus y is not equal to z. Now we need to consider why won't a counterexample suffice. Now the reason why a counterexample won't suffice is because the negation of the statement is for any integers x and y, there has to exist this z that does not equal it. So just giving one counterexample would not be sufficient. Essentially, we have to come up with an algorithm that would show that this could not be the case. So we want to consider how we can always find this one integer z that's not going to equal to x plus y. So we're going to say for any x and for any y, let z equal x plus y plus 100. In this case, for any integers x and y, z will never equal their sum. So that is how we could construct essentially an algorithm to show that the negation is true.